Okay, now we're going to start an example on how to assess a roundabout from scratch, just based on the Google Earth image. So that's the picture that has the roundabout. That's what we saved from Google Earth. So that's basically our roundabout. Okay, so what we're going to do, we're going to just take it and grab it and import it into AutoCAD. So we open AutoCAD. That's the old one that we tried before. So we're gonna just remove it and can just copy it from the directory. Click Control C. I'm sorry, Control C. Then you come here and push Control V. Okay, so that's it's inserted here, but you can see it's very tiny. So now we need to scale it. So in this case, we are going to scale it up. So how can we scale it up? That's the scale line. So that means this distance in reality is 63 meters. And if 1 unit in our drawing equal 1 meter, then if we draw a line just from the middle of this to the middle of this one, you see that this distance, it's 2.3228. So we want this to be scaled. We want this image to be scaled such that if we draw this line, it's going to say 63 meters. So how can we do that? Divide the 63 that we see, there, divided by 2.3228. So that means we need to scale this picture 27 times up. So we go here and modify and select scale and select the image. Once it has this blue border line, then it's been selected. Click enter and click this corner. And now we are going to put the number here. It's 27.12244. Okay, so that's the image after scaling up. So we want to check to see if our scaling is correct or not. We go again and try to draw a line here till here. How much is saying? 63.165. We can live with that. This is acceptable. Okay. So now we have our image, our roundabout image is scaled to the okay. Now we need first to make our first assessment. What was the first assessment? Do we have the elements of the roundabout here or not? Okay. First of all, do we have entry lines here? Let's focus. Do we have entry lines here? No, apparently we don't have any entry lines here. That's one. Another issue here, this is a bypass lane for the right turn. Is it isolated from the roundabout? No. So it's kind of the roundabout here diameter is variable or not consistent. Let's draw a circle to see. So that's the circle. Okay, so that's almost the roundabout. You can see here. Okay, let's measure the diameter. Go to annotate and scale. Look for the diameter. So the diameter here is 92.44 meter, 92.44, which is within the acceptable range. So the diameter here is no problem. Okay, what is the problem? The problem here, do we have entry lines, we don't have entry lines. So we can just go here and draw this, mark it. I'm sorry, can just erase it. You can just mark it in with an image, with a marking lines or something like that. Okay. Let me just look for something here. Okay, so here, this area, for example, we don't have an entry line. Uh, do we have pedestrian crossing? Apparently no. Okay. Do we have sidewalk? No. Do we have buffering, preventing pedestrians from? Of course we don't have a sidewalk, so we don't have any. So that's one. Do we have a splitter island here, for example? Let me just grab this picture and let's put it on PowerPoint. You just hold for a moment, Sanad. Okay. Okay. Here, let's make our comments, on both AutoCAD and on. So the diameter or the size, we have no problem with it. Okay, but okay, here we don't have pedestrian crossing, and we don't have entry lines. No pedestrian crossing. Okay, we know entry lines. Correct? That's one issue. Here, for example, we don't have splitter island. Okay, that means someone can make this maneuver, can go. So, someone can make this turn, for example. Okay, uh, that's one issue. Another issue we need to check, the entry speed. As you can see, the radius here will be very high. Let's look at the AutoCAD copy of this and see how things will go. Okay, let me draw a polyline. Just by this is a trajectory for a vehicle. Okay, just draw. Okay, let me just go from here. Okay, okay, it's snapping to objects. Okay, so that's let me just change the color of this to be visible better. Properties for better visibility. I'm going to change the color, so it's going to be red. So that's basically, actually, this is not 100% accurate. So if we move this a little bit here, and this can be moved here, this here, for example, that's more of a realistic trajectory. Okay, so as you can see, that's the entry curve, correct? Let's see what radius do we have here. That's the entry curve, 141. Okay, so that's the inscribed diameter for the roundabout. That's the entry radius. Okay, so the entry radius, how can we convert this to into speed? Simple. We can convert this into speed. Okay, no, not this one. Okay. Okay. So that's basically the entry. Oh, sorry about that. That's the radius. That's the entry radius. So basically, I don't know why this is keep. Okay. Forget about this. Let's go back here. So basically, we have V square over G R equal E plus F lateral. Okay. Usually in roundabouts, the either there is a super elevation like this, 1.5%, and that's the island. So this is basically for draining water, okay? Or sometimes the island is, and there is 1.5%. So in this case, I'm going to take the worst case condition, which is this one. It's going to be negative in this case. So V square or V equal square root of G R E, which is minus 0.015 minus plus the lateral friction or the lateral side friction. The lateral side friction, we can get it from the charts that we have before, or the charts that we studied for designing horizontal curves. It comes from here. So if we assume the entry speed, for example, let's start with 70. Okay, and let's just substitute here with 0.15. So V1, because this is going to be iterative, V1 equal how much? square root of 9.81 multiply the radius that we measured. It was 140 something, I think. 141. 141 multiply 0.135, and all of this under the root. So how much this will be? This is going to be 9.81 multiply 141 multiply 0.135. So that's 186 under the root. So this is 13.67. 13.67, 9.81 multiply 141 multiply 0.135. Okay, under the root, answer. Okay, so this is, the unit is going to be meter per second. Okay, for kilometer is going to be multiply 3.6. So it's 49 kilometer per second. So let's go back and check also the radius here, because this is the first term, then that's going to be the second radius. So let's look here. It's 194. Okay. So that's the second entry. Let me just change the properties and make it different color so it becomes visible. So that's basically 194. Try to substitute for 194 here also. If this one becomes 194, the speed will be a little bit higher. So 194 multiply 9.81 multiply 0.135. Okay, under the root. So it's 16. If this one 194, here it will become 16. I'm sorry. 16 meter per second, which is basically 57 kilometer per hour, which is acceptable, by the way. This is not bad. Okay. And the main reason for this, despite all the deficiencies in this roundabout, okay, is basically that the gross diameter of the roundabout is reasonable, is small. If this roundabout was, or maybe the trajectory that we draw was not, could have been, more severe. Anyway, there is another check we need to make. Let me draw this. If someone comes from this lane, he can go opposite traffic. Let's see if this can be achieved or not. To check for that, let's go to CAD tools. And let's emulate a vehicle. Simulating here a car. Let's go to a passenger car. And we are going to execute it here. Okay. So you can see that it was able to make that turn easily. Okay. That's why, because there is no splitter island to prevent that. So someone can go and make this turn, easily. There is another check we need to make also, which is the accommodation for heavy vehicles. I don't think there is a problem here. There's another issue, which is basically the alignment with lanes. Okay. There's a problem with the alignment with lanes here, because you can see that, you can enter, there is no real alignment for the lanes. You see the lanes going directly to that. So that's one. And also the exit. You can see it here even, that there are parts of this roundabout that are not being used by the traffic. You know what I'm talking about? You can see it here. For example, this segment, it's dusty and has a different color because no traffic is using this part. And the same here. These are signs of poor geometric design. Okay? So this is how I need you to prepare your report for the homework. You highlight your observations, your findings. Of course, you can see here, there is no signage. مفيش لوحات إرشادية هنا. تمام؟ ولا في لوحات، في عمود نور هنا، في عمود نور. مفيش أي معلومات تانية. في أسهم هنا تقول لك أنت رايح فين وجاي منين. مفيش أسهم. واضح يا شباب؟ أي سؤال؟
دكتور،
يس.
أنا واجهتني مشكلة في الكاد تولز، ما أشتغل معي أبد يعني.
ليه؟
ما أدري والله، حملته أكثر من مرة ونفس المشكلة، يقول إنه لا يستجيب، ما أقدر أضغط على شيء.
ركز معايا. انت ادخل على السيتنج، go to settings and select the CAD version and parameter.
دكتور،
اوكي.
المشكلة ما أقدر أضغط حتى على السيتنجز، نفس الخانة هذه كاملة ما أقدر أضغط عليها.
ليه؟ يعني بيظهر لك ده كده frozen.
بالضبط، أي يكون عليه كذا أبيض شوي، فما أقدر أضغط على شيء.
غريبة دي. فهمت. ده في الغالب هقولها لك، لو مثلا انت حطيته مثلا كده CAD 2 او CAD 2004. اوكي. هقفل وافتح تاني. هنا بيجي لي مسج لو wrong version. So are you getting wrong version or what?
لا دكتور، أنا أساسا ما غيرت حتى الفيرجن من أول ما حملته، وهو مو براضي حتى يوديني لا سيتنجز ولا حتى ما يطلع لي علامة إنه في شيء مشكلة.
Okay, we can discuss it later after class. You can share with me your screen and we will see what we can do about that.
أوكي.
Okay. Okay. Anything else?
دكتور،
Yes.
كيف نسلم الواجب؟
You are gonna write a report and include, an image like this with your observations, with your remarks, and write a report about this.
ايه يعني بالوورد ولا كيف دكتور؟ ولا بالاوتوكاد؟
هتاخد ايمج من الاوتوكاد عليه الدايمنشنز والحاجات اللي انت عملتها. تمام. وهتحطها في الاوتوكاد ده يا شباب مش هوم ورك، ده بروجكت، ده سمول بروجكت. تمام. هتاخد كل اللي انت عملته هتحطه في الوورد. تمام. هتحط صورة زي كده وتحط ملاحظاتك وتشرح عليها مشاكل وايه زي ما انا رسمت هنا. تمام. هتاخد من الاوتوكاد الايمج اللي هو زي كده بالراديوسز، بالابعاد، بالويل تراكس بتاعت كارز، توريني انت عملت ايه. ماشي.
تمام دكتور.
خالد العتيبي اللي كان بيسأل ولا مين؟
ايه.
ماشي. اوكي. ده اصل انا بختبر نفسي يعني، انا كده يعني. اوكي. اي سؤال تاني يا شباب؟ خالد يا جرني،
لا دكتور.
كل شيء واضح دلوقتي؟
اي الان وصلت الفكره. ممتاز.
ماشي اوكي. معاكم لغايه يوم الاحد القادم. اوكي.
اوكي يا دكتور، يعطيك العافيه.
الله يعافيك. اي سؤال تاني؟ انت بص عشان ابقى واضح معاك what we are looking for. لا مش دي. في هنا انا اتكلمت على الديزاين elements. اوكي. يعني مثلا بايسيكل تريتمنت دي ما هي مش موجود عندنا اصلا موضوع البايسيكل تريتمنت. تمام. لكن هنا انت ممكن تبحث او في ليست هنا. شايفين الستة بوينتس دول؟ اوكي. you must answer these 6 points. هل الراونداباوت providing slow entry speed؟ هل providing appropriate number of lanes and lane assignment، يعني النمبر اوف lanes consistent في الراونداباوت؟ اوكي. هل في smooth channelization؟ هل في adequate accommodation for design vehicles؟ تمام. دي جزئيه. الجزئيه الثانيه هتراجع بقى على الايه، الدايمنشنز والنمبر اوف لينز واللوكيشن والدايمترز، وبعدين تبص على العناصر دي. واخد بالك؟ مش دي بالظبط، دي في عندي هنا pedestrian crossing. اوكي. الديامتر ده شكله ايه؟ هل في عندي انتري لاين؟ تمام. وهكذا. واضح؟ يعني تشوف انت الديزاين فيتشرز والديزاين اوبجكتيفز. اوكي. الفيتشرز اللي هي هنا في سبليتر ايلاندز، في سيركلاتوري رود واي، ابرون، يلد لاين. خلي بالك في راوند اباوتس ما فيش فيها ابرون لان هي مش محتاجه ابرون، الديامتر بتاعها واسع. واضح؟ اوكي.
اوكي.